So welcome to chapter 10. So we're going to continue talking about comparisons involving means, but now we're going to look at what if we have two different samples that we're wanting to compare. And so if we have two or more random samples that are independent, so what this means is we've collected sample one and then completely independent with a different data set, with a different methodology, but with a different sample, we've collected sample two. So they're completely independent. It's not like, oh, if you weren't in sample one, then you could participate in sample two. No, we did them completely independently. And so that the samples are very clearly delineated. Now, ideally, the sample sizes would be the same, although they don't have to be. It is a good practice to make sure your sample sizes are similar in size. So you don't want, like, let's say a sample size of 10 comparing with the sample size of 600. There are situations where that is appropriate just because of the nature of the data, but if possible, we'd like to have our sample sizes close in size. So we let mu1 be the mean of the first population and mu2 be the mean of the second population. It really doesn't matter which one you designate as sample 1 and which one you designate as sample 2. 1 isn't better than 2, 2 isn't better than 1, but you do need to make sure that you are consistent. So for example, if we're comparing salaries between men and women, we may designate men as 1 and women as 2, but then we want to make sure that we are consistent with that and we don't mix them up. So first of all, let's talk about the confidence interval for just a minute. We're going to come back to confidence intervals later. So if we're looking at the confidence interval for the difference between mean 1 and mean 2, we're going to use the sample mean for sample 1 and the sample mean for sample 2 and the difference between those as our point estimator. Now we are going to assume, we have to be able to assume that both samples are normally distributed. If they're not, remember, according to the central limit theorem, as long as the sample size is greater than 30, we can assume that they're normally distributed. So if we're not sure, we just got to make sure we have a sample size that's large enough. But again, both sample sizes have to be greater than 30, not just one and not combined, but both independent samples. So let's talk about some different scenarios that we have. So we may know the variance and the standard deviation, in which case we'll use the z-test. If we don't know the variance and standard deviation, but we can assume that they're equal, then we'll use our t-statistic with certain degrees of freedom with a pooled estimate of the variance. And if we don't know if the variances are equal and we cannot assume they're equal, then we'll use the t-stat with a distribution for sample 1's variance and sample 2's variance. So when we're doing our hypothesis test, a lot of the time we're testing to see whether the means are the same or different. So our null hypothesis is that the difference between the means is 0. So that d sub 0 there is, for the null hypothesis, is saying that the difference is 0. Now we can test, for example, we might want to say, oh, is the difference 20? And so it is possible to plug in a different value there, but most of the time, a lot of the time anyway, we're testing just to see whether they are different. And so then we're just testing to see if the difference is 0. If we're looking at a right-tailed test, then we're testing whether mean 1 minus mean 2 is less than 0. So this is really testing to see whether mean 2 is greater than mean 1. And then for a left-tailed test, we're testing to see whether mean 1 minus mean 2 is greater than 0, greater than or equal to 0. So that's testing to see whether mean 1 is larger than mean 2. So notice how it's written. A right-tailed test is testing to see if mean 2 is greater, whereas a left-tailed test is testing to see whether mean 1 is greater. And as we discussed in chapter 9, remember the null hypothesis is always the one that has to have the equality in it, whereas the alternative hypothesis, what we're actually testing for, does not have the equality, it has the inequality. Now I'm just going to show you these formulas. Of course, we're going to do this in Excel, which is I'm very grateful for because these formulas are kind of nasty. So if we know the variance for both samples and both populations, rather, if we know the variance for both populations, then we'll calculate our z-score. And here's our very fancy formula for our z-score. If we don't know the variances, but we can assume they're equal, then we use this formula for our t-statistic with a certain degrees of freedom, where the degrees of freedom are the sample size of 1 plus the sample size of 2 minus 2. And then we have our pooled estimate of the common variance, and you can see where we calculated that down at the bottom. And again, that's a really ugly, nasty formula, and I'm very grateful that we have Excel to do this in. And then lastly, if we don't know the variances and we cannot assume they're equal, then we have again our nasty formula, but now our degrees of freedom is not so simple to calculate. We've got to do that formula down there at the bottom. But again, don't worry, we're going to use Excel, so I'm very excited about that. Now, if we are not given all of the data for a problem, then we can just calculate the z-score and then calculate the p-value, like looking up in the z-table or using that norm formula like we did in Chapter 9. But if we're given all of the data like we are in this example, so we're looking at example 10.4, where we have the annual return for 10 firms in the gold and the oil industry, and we're looking at a 5% significance level, are the returns different? So our null hypothesis is that mean 1 minus mean 2 is 0, and our alternative hypothesis is that they are not equal to 0. We're just looking to see, are they different? Now, you can see our data here, and of course it's in our Excel spreadsheet that we're going to jump over and look at in just a moment. But we're told that we can assume that the populations are normally distributed. The population variances are unknown and unequal. So again, that's that really ugly formula that we saw just a slide or two before, but we're going to do it in Excel. So again, yay for Excel. So in Excel, we have this data analysis tool pack. So I'm going to show you this screen here, and then of course we're going to jump into Excel and do it ourselves. We're going to, again, open our Chapter 10 workbook and go to the Gold Oil worksheet. And when we do that, we're going to go then to the data analysis function, which you should have already added in, but if you hadn't, then you might need to go in and add it in. We're going to do a two-tailed test, because remember, we're looking at whether it's equal or not equal, so remember that's a two-tailed test. If we're looking at one with an inequality, a greater than or less than, then that's a one-tailed test. But for a two-tailed test, we're going to do this one. And then we'll just plug in our data here and it will calculate it for us. So let's jump over to Excel now and work through this together. So here I have my gold oil worksheet pulled up, and you can see the tab down here in the Chapter 10 workbook. Now I'm going to go to the Data tab at the top, and notice over here on the far right in the Analyze group, I have something called Data Analysis. If you don't have this here, you should, but if you don't, then you'll need to go do that File, Options, and Add In like we did earlier this semester. So maybe if you've changed your computer since then, or you're working through a different computer, you may not have it there, but you should. So I'm going to click Data Analysis. Now there's lots of things here that we see, and we've already used some of these. We've already used descriptive statistics. That's how we added in this the first time. We've looked at the histogram, but now we're going to come down here to the t-test. Now notice that there's 3 different t-tests and a z-test. So which one of these we're going to use depends on what kind of data we have. We have 2 sample assuming unequal variances. So this is the t-test that I want to use, the one that I have highlighted here. If we know, for example, that the population variances are known, then we'll use this z-test, the 2 sample for means. And if we don't know the variances, but we assume they are equal, then we'll use this t-test for assuming equal variances. But since we're told to assume they have unequal variances, I'm going to choose this one with unequal variances. I'm going to click OK, and I bring up this dialog box here. Now, in variable range 1, I'm going to highlight gold. Now, I'm going to highlight the label also. You don't have to, but I'm going to. And in variable range 2, I'm going to highlight oil. Now, again, it doesn't matter if we say gold is 1 and oil is 2, as long as we keep it straight. It matters when you're doing the test, the tailed test, but not when you're doing a two-tailed test. So I am hypothesizing that the mean difference is 0. If I were hypothesizing that the mean difference was 20, then I would plug in 20 here. I did choose my labels, so I'm going to check this box for labels, but if I hadn't grabbed the gold and oil label, then I would uncheck this box. And then alpha is my confidence interval. So I wanted 5% confidence, so I'm going to put 0.05 here. Again, if you just type in a 5, then that's 500 confidence, because you have to convert these from a percent to a decimal. If we wanted 90% confidence, we'd put a 0.1 here. If we wanted a 99% confidence, we would put a 0.01. And then I have different options for how I want my output. So I can put it on a new worksheet, in a completely new workbook. I want to leave it here on this worksheet, and I just want it to start in D1, so I've just selected D1 here. And now I just press OK. Now I'm going to make this a little bit larger here so we can all see it. All right, so notice that it gives me both the mean for both the gold and the oil, the variance for both, the number of observations, so the sample size for both, the hypothesized mean difference, remember I said was 0, the degrees of freedom, so it did that ugly calculation for us and got 17. Now it gives us lots of statistics down here, so we have to be careful. We want to make sure we're choosing the one that we need. So remember, this was a two-tailed test, so that means I want this. This is my critical statistic right here, the two-tailed test. Okay. So since this p-value is not less than 0.05, I cannot reject the null hypothesis. So I cannot say with 95% confidence that the returns from gold and oil are significantly different, okay? I can see that the means are different. Oil has a slightly higher mean return at 17.3% versus 16% for gold, but that's not a statistically significant difference with 95% confidence. So I cannot reject the null hypothesis in this situation. So I'm going to pause. So let's jump back over to our PowerPoints here. And again, we can see that the output, the data I put here also in the slides for us. So we've already said that because the relevant statistic, the one that we were looking for, that 0.7661 is greater than 0.05, our 5% significance level, we cannot reject the null hypothesis. So again, we talked about that even though the returns are different, they're not statistically different. Now, we can calculate a confidence interval between the two means. And so just to refresh your memory, the formula for our confidence interval is the mean of sample 1 minus the mean of sample 2 plus or minus the t-statistic with certain degrees of freedom multiplied by the square root of the standard the variance for sample 1 divided by the population size and the variance for sample 2 divided by the population size. So again, we can calculate this in Excel. So let's jump back to Excel. So the great thing about Excel is that they've already calculated so much of this for us. So if I wanted to calculate, let's say, the upper limit, I can go ahead and remember my formula is the mean of sample 1 minus the mean of sample 2. So I'm going to start with my equal sign, open my parentheses, mean of sample 1 minus mean of sample 2, close my parentheses. Now for the upper limit, remember I'm adding. When I do the lower limit, I'll subtract. So I'm going to add. Now the t-statistic they've already calculated for us, so that's down here in cell E12, this t-critical two-tail, because this was a two-tailed test, so that's that 2.109816. Multiply, use my asterisk to multiply. Now I want the square root of, now this is where we've got to be careful with our parentheses. I want the square root of the whole thing, so I'm going to open two parentheses. The variance for gold divided by the sample size for gold, close one set of parentheses, plus, open a second set of parentheses, the variance for oil divided by the sample size for oil, close that set of parentheses, and now I'm going to close the last set of parentheses. So now it's taking the square root of everything within those black parentheses. And so that means my upper limit is 7.772077. Now to calculate the lower limit of my confidence interval, it's the exact same formula, except I want to subtract instead of add here. So I'm going to go in and I'm going to press F4 all the way through for every cell reference so that when I drag, the cell references won't change. Right, so now I'm just going to drag the formula down, and in the lower limit formula, I'm going to go up and change this plus sign to a minus sign. So the one right between the difference in the means and the multiplication of the t-statistic by the square root. And so I get my lower limit of negative 10.3722. So since the 0, which was our null hypothesis, that the two means equal 0, since 0 falls within my confidence interval, because that goes from negative 10 to 7, then that is another further proof or another way to analyze it that we cannot reject the null hypothesis. If we could reject the null hypothesis, then 0, the null hypothesis, would not be in the confidence interval. So if we work it out mathematically here, again, I just pulled all of these numbers off of our Excel, and we work it out by hand, we still get negative 10 to 7.77. So again, we get the same thing. So again, I mentioned this in the video earlier, but I wanted you to have it written down here in the PowerPoints, which test we're going to use. So again, if you know the means, you use the z-test. If you don't know the means, but you assume if the variances are unknown, if the variances are known, we use the z-test. If the variances are unknown but assumed equal, we use that particular t-test, and then otherwise we use the two-sample assuming unequal variances. Now I want to point something out here. You'll notice if you're following along and reading in your book that your book has a lot of extra practice for you. For example, on page 339, there's several different practice sets there that have the data built into that chapter 10 workbook. So I would encourage you to go through and practice those also, maybe even before you jump into the homework.